Hey guys, so welcome back to your next class of Catalyst Concepts. In the previous class, we were looking at how energy is necessary for any form of work to happen. Right? We also spoke a little bit about how uh, different types of energies are there and each of them can do work in some form or the other. So today we'll start talking about these different forms of energy, and we'll start with one form that we are, I think, very familiar with. Okay, so I'd like you to think about a game like if you talk about carom board. You remember carom board is a game that we play, right? So you must have played it or seen it at some point in your life. What do we do in carom boards? You have these little round coins, kind of like thing. You have a striker and these little coins on this board, and you hit the striker with your finger, and then it's going to go and hit these coins, right? The moment this striker, the one that you hit, it goes and hits the coin, what happens? That coin is going to start moving, right? It will start flying all around the board. Okay. At the same time, what's happening is your striker is going to slow down. The moment it hits the coins, it's going to slow down a little bit on its own, and the coin starts moving fast, right? And then your aim is to somehow drop a coin in the holes. That is the whole game of carom. If you also look at another game, talk about cricket, for example, someone's throwing a ball, right? A ball comes moving, and then you just take a bat, you swing it, and you just hit the ball, and then it goes flying off in another direction altogether. Okay. In both of these cases, one thing you have to notice, right? We use a moving body to create some sort of work, right? Can I say that I've used a moving body to create some sort of work? It could be the bat that I swung to hit the ball. It could be the striker that I flick so that it goes and hits the coin, right? Now, both the bat and the striker are doing the same thing. They're making another object move, or let's say displace. Okay, so carom and cricket, both of them work on displacing another object, be it the ball or the strike or the coins. Since they're displacing something, I can say definitely that we are doing some work when that is happening. Some work is happening on these objects that are moving. Since displacement and force applied is going to give us work. So what form of energy am I using when I use a moving body, like a carom coin or anything that moves, for instance? So we say that any object that moves, okay, any object that moves will have something called kinetic energy. Okay, kinetic energy. Okay, so this is one form of energy that can help us to do work. Now, any body in the world that is moving has kinetic energy. It doesn't have to be just these examples. Even when I am moving, I have some kinetic energy. Right? Even if you drop an object from a height, it will have kinetic energy because it's moving. Even if you, let's say, mm, throw throw a pebble, right? Anything that moves basically will have kinetic energy. Is what I'm trying to tell you. Okay. And this kinetic energy, when it gets transferred from one object to other object, some work will happen, right? So what exactly is this kinetic energy and how do I measure it? Okay, so let's talk about the carom board example because it's a very easy thing to refer to. Okay, when you start playing your carom boards, none of your objects are moving. Okay, your striker is not moving, your coins are also not moving. Okay, so let's talk about the striker in specific because that's the one that we are hitting. Okay, initially it is an object that is at rest. If your striker is at rest, obviously it cannot hit the coins, right? Because it has no energy, it cannot do anything, or it cannot even move on its. This striker, when it's at rest, we try to put it in motion. we try to make it move. For that motion to happen, we are giving it energy from our own end, right? We are doing some work, right? We are doing some work on it by giving it energy from our finger or our hand, right? If you keep on playing, you can't play forever. It's quite simple. Once it gains that energy, that is when it will start to move, and that energy is nothing but kinetic energy. Okay. Once it gets this kinetic energy, it will start moving, hit another object, and then it will make the other object also move. Okay, so it will transfer to point. This is what I'm trying to say. Okay, I hope this much is clear. So this is a sequence of events that comes whenever any object is trying to get what we call kinetic energy. Okay, so how do we measure this kinetic energy? Because if a body has kinetic energy, it has to be measured because every body has a different amount of kinetic energy, right? The faster you're going, the more kinetic energy you would have. So let's take a simple example of an object on a table like this, right? Now, say that it is here and it's on rest, okay? And you push this with a certain amount of force and then it displaces to some distance and moves up till here, right? So since it has moved, I can say that if it gained energy, right, the object gains energy only when I give it. So I can say that the work done by me on the object is nothing but the energy gained by the object, right? Because energy is something only transferable. If I give it, someone else has to take it. So I will say that the work I do is F into S. Okay, now uh, S is the displacement of the object, F is the force that I give. Okay, now I can say that we know that force equals to mass into acceleration. Right? It's a very basic formula that we learned. So I'm going to write this force as mass into acceleration. Okay, just write into also here. Mass into acceleration into S. Okay. Now, if you remember, in your motion chapter, we had one formula. That is a relation between V and U. Okay, it says V square minus U square equals to 2AS. Right? If I rearrange this formula, I can make it like this. V square minus U square divided by 2A equals to S. I put this 2A on, I cross multiplied it. Right? So I will be using this value in the place of S. Okay. Just to tell you, V and U are nothing but initial and final velocities of the body. Okay. So if I talk about this block, it's starting at U, and then once it starts to move, it takes a velocity of V. And since we know that the object is not moving in the starting, it's at the rest, I know that U's value will be 0. Okay, so let me first simply write this down. M into A into V square minus U square divided by 2 into A. Now I can cancel this A from here and A from here. Okay, so I am left with M into V square minus U square divided by 2. Now we know that U value is 0 since the starting velocity is 0. Final velocity we don't know, it can be anything. So I'll say M into V square minus 0 square, which is 0 divided by 2, which is nothing but mv square divided by 2. So this is nothing but the kinetic energy gained by the body, or the kinetic energy that is given out by me towards the body. Okay. So this is the formula to calculate kinetic energy for any object. You just need the mass of the object or however it is and the velocity gained by that object. It does not depend on any other factor. Okay. Now this is one formula that we are going to be using going forward so that we can solve sums, right? Now if you see, uh, kinetic energy depends on the velocity. Okay, if the velocity is higher, it means the kinetic energy is also higher, meaning more energy will make my object go faster. Less energy means object is gonna go slower. It's quite an obvious thing, right? An object going fast has more energy with it going slow, has slow energy. Okay, so just remember the connection. More kinetic energy means faster object, more velocity. All right, so we'll pause here for today. Just to recap, kinetic energy is nothing but energy possessed by an object due to its state of motion or due to its movement. Okay, and we can measure the kinetic energy of an object by measuring how much work we did on the object for it to get the kinetic energy, right? And if we simplify this work formula, we can find the kinetic energy. The formula for it is half mv square. Okay, m where m is the velocity, m is the mass of the object, v is the final velocity gained by the object. Okay, so that's it for now. We'll continue in the next class. We'll look at how to solve for numericals to measure our velocity. Okay. If you have any questions, please drop them in the comments below, and I'll see you in the next class. Thank you.